All right, we're going to go ahead and do Unit 7.3 is on special exponential functions. So we're going to look at a new number. It's an irrational number, and the symbol for it is e. And you have an e to the x button on your calculator. All right, so you're looking for an e to the x button. It's probably on your calculator, especially on my calculator anyway. Look for an ln key. All right, so look for ln, and then just above that ln is the e to the x usually. So you have to hit the second key and then ln to access that e to the x button. All right, and so if we want to know what e actually stands for, or what its representation is of a decimal, you're going to put in e to the first power. All right, and so if you put in e to the first power in the calculator, it's going to be approximately 2.718, and it'll just keep going on forever. All right, again, just like pi, the symbol for pi is, right there, and then its approximation is 3.14. Again, it's a decimal, it just goes on forever. All right, and so we're using the symbol e, and again, it's 2.718 approximately. And we use this e number typically in finance problems. And so when we want to calculate compounding interest, anytime it says it's compounding continuously, we're going to use this formula a equals p times e to the rt. So r times t is going to be in the exponent of the e. All right, so again, what each of these letters represent, a is the ending amount, p is the starting amount, again, it's called the principal, what you invest. E, we're going to just leave E in the formula because we're going to use the e to the x button on the calculator. R is going to be the percent as a decimal, and then T is going to be time in years. All right, and so we can simplify e to exponents, just like we did with x's. You can try to treat e like a variable when you're asked to simplify, and we're just using the exponent properties. So we're not going to actually use the decimal on these. All right, so e to the 7 times e to the negative 2. And so when we multiply like bases, again, we want to remember we're adding exponents. So it's 7 plus negative 2, and then that's e to the 5th power. All right, and we just leave it just like that. If we wanted to know what its decimal is, we could put e to the 5th in the calculator. All right, b, we're dividing, so we're going to simplify fractions first. So 40 over 14, we can divide by 2, and so that's going to be 20 over 7. And then e to the 5th over e to the 7 over e to the 5th. Since we're dividing, we can subtract the exponents. Again, we want to bring the smaller to the bigger, and so we can bring the 5 up. And so we're going to get e to the 7 minus 5, or e to the 2nd power. So 20e to the 2nd over 7. All right, and then c, since we have exponent and it's raised to an exponent, we're going to multiply the exponents together. Remember, this negative 3 has an exponent 1, and so that 1 is going to get multiplied to the 4, and the 2x gets multiplied to the 4. All right, since negative 3 is being raised to the 1st power, now negative 3 is being raised to the 4th power. All right, so 1 times 4 is 4, and then e 2x times 4 is 8x. Now, negative 3 to the 4th, you can put that in the calculator if you need to, but we can simplify that. That's going to be positive 81. All right, and then e to the 8x. So we want to use parentheses because negative 3 is in parentheses. So when we raise it to the 4th power, negative 3 still needs to be in parentheses. All right, example 2. All right, so here's a word problem. Mr. Walker deposited $1,500 in a savings account that pays 3% annual interest compounded continuously. All right, so we're going to use this formula, a equals p times e to the rt. All right, what will the balance be after 4 years? All right, so what the numbers represent in this problem, depositing $1,500, that's our p value. Interest rate is 3%, so r is 0.03. Compound continuously. And then in question A, it says, what's the balance after 4 years? 4 years is time, that's t. So plugging those numbers into this formula, A equals 1,500 times E We're going to raise that to the 0.03 times 4. All right. Now, depending on your calculator, you could just throw it all in like that. You could do this in steps, like find the exponent first, 0.03 times 4, which is 0.12. All right, and then we could do, let's see, 1500 times e. So you're going to go second ln, and then we're going to do e to the 12th, let's see, 0.12 power, 0.12. Enter. All right, and we're going to round to nearest cent, so that's 2 decimal places. All right, so it looks like it's going to be $1,691.25. All right, and then question B, how much is in the account after 10 years? Again, we'll do the same thing. We're just changing t now to 10 years. So e to the 0.03 times 10. Right, again, you can just do 0.03 times 10 if you want to first. That's 0.3. All right, so now we can put that in the calculator, 1500 times e, and that's being raised to the 0.3 power. All right, and so then after 10 years, looks like there's going to be $2,024.79. All right, graphing. All right, so we're going to graph just like we did with the regular exponentials from 7.1. And so remember, e is about 2.718. And since e, which is 2.718, is greater than 1, this is an exponential growth problem. So the graph will look similar to all the other exponential growth problems. So using an XY table, we can use -1, 0, and 1 for x. All right, and then we plug it in. This is the parent function, e to the x. And then plugging each of these numbers in, we can find its y value. So putting -1 in for x, so that would be e to the -1 power. And so you're going to get 0.3678779. It just goes on forever. And so we can just round this to 0.4 is fine. Plugging 0 in, e to the 0, that's going to be 1. And anything to the 0 power is 1. And then e to the first is 2.718. And so we'll just use 2.7. All right, there's no transformations on this. Again, the asymptote, horizontal asymptote, is always the k value, and in this problem, there is no k value, it's 0, so we have a horizontal asymptote at y equals 0. The y-intercept, again, just plug in 0 for x, and if you simplify that, e to the 0 power is 1. All right, so let's go ahead and plot this. -1.4. 0, 1, and then 1, 2.7, that's almost 3, it's about right there. All right, again, this is going to have the same shape as all the other exponential growth graphs, so it goes to the left, and it's going up. A domain, -infinity to +infinity. The range looks like it's going to be 0 to +infinity. Again, we'll use parentheses on the 0. The horizontal asymptote, again, hits right here on the x-axis. It's the k value, which is 0 in this case. All right, example 4. Y equals 2 times e to the x plus 3 minus 4. All right, so again, make our xy table. Our parent function is just y equals e to the x power. Okay, so again, we're going to use -1, 0, and 1. And plugging those in for x, they're going to be the same y values that we did on the previous problem. You don't have to memorize those y values because you can just plug -1, 0, 1 in for x and get the y values. All right, so e to the -1, again, we just put it in the calculator. Okay, 0.4 e to the 0 is 1, and e to the first 2.718 or 2.7. All right, so that's the parent function. Now we'll do the transformations. So the x plus 3, since it's a binomial, that affects the x's. It does the opposite, so we're going to subtract 3. And then on the y's, we're going to first multiply by 2 and then subtract 4. All right. So the x is -1 minus 3 is -4. 0 minus 3 is -3. 1 minus 3 is -2. All right, the y's, go ahead and use the calculator on this. 2 times 0.4, and then that's 0.8, and then minus 4. So it's -3.2. All right, then plugging 1 in. 2 times 1 is 2. 2 minus 4 is -2. All right, and then we'll plug 2.7 in. So 2 times 2.7, and then that's 5.4, and then minus 4. So 1.4. All right, so let's plot those 3 points. So -4 down -3.2. That's about right there. -3, -2, -3 down to -2. -2, positive 1.4, -2, positive 1.4. All right, we want to put our horizontal asymptote in. So again, it's y equals the k value, and k is -4. So we can put that in. Okay, right at y equals -4. So that's our boundary line. The graph can't cross or touch. So you should see the shape of this graph now. Okay, it's going to go to the left. It's going up. The domain, -infinity to positive infinity. And the range, it's going to be -4 to positive infinity. Oh, we need the y-intercept. Sorry about that. So here we'll just plug 0 in for x in the original problem. So 2 times e to the 0 plus 3 minus 4. So that's 2 times e to the third power minus 4. And we'll go ahead and put that in our calculator. Put it all in just like that. 2 times e raised to the third. And then if you want it equals, you can. And then just make sure you hit minus 4. All right, so it looks like it's about 36, well, round to the nearest tenth, 36.2. All right, it's going to be way up there, 36.2. All right, and last two problems, it's just solving exponential equations. This is review from really 7.2, where the bases are the same, and then we can drop the bases, set the exponents equal. So on 5a, the bases are the same for both e, so we can just set the exponents equal to each other, and then solve for x. So here I can subtract x over x equals 3. Okay. And then b, same thing, but we have two e's on the same side, so we want to combine those together first. And since we're multiplying like bases, we add the exponents. So it's e to the 3x plus 2 equals e to the 12th power. All right, and then the bases are the same. Set the exponents equal. And then just solve for x. 10 over 3 doesn't simplify, so we'll just leave it like that, 10 thirds. All right, and that's it for this lesson.